Sometimes when we're going to run into situations that are not easily factorable, so we're going to use this rational zero test to see if we can come up with a way to at least get started. So the rational zero test, if you have a polynomial f of x equals a sub n times x to the nth plus a sub n minus 1 times x to the n minus 1 plus all the way down to some constant a sub 0. It's got, as long as these all have integer coefficients, our rational zeros are going to be in this form, p over q. Now, the p values are factors from your constant term, your a sub 0. Your q's are factors from your leading coefficient, the a sub n. So, in general, we've got the possible rational zeros are the factors of the constant term divided by the factors of your leading coefficient. This is going to require a little bit of work, but we're going to use a calculator to kind of speed up the process as well. So, for the function f of x equals x to the fourth minus x cubed plus x squared minus 3x minus 6, we have to come up with our p's and q's first. So p's, those are going to be factors of negative 6. Now, factors of negative 6 could be like plus or minus 1, or plus or minus 2, plus or minus 3, plus or minus 6. So technically that's 8 different factors, the positive and negative versions of all of them. Q, they're going to be factors of your leading coefficient. In this case, our leading coefficient is 1. So 1 is its own factor. So it'll be 1, or we could also say positive or negative 1. So now that means for our p's divided by q's, we're going to take all those p values and divide it by all those q values. Well, thankfully there's only one q value. So when we do positive or negative 1 divided by the q value of plus or minus 1, you're going to get, well, just plus or minus 1. And plus or minus 2 divided by plus or minus 1 is also just going to be plus or minus 2. And the rest of it holds true. Now, for these purposes, what I would encourage you to do is graph it on a graphing calculator to know where to start. So, for example, if I were to graph this in a graphing calculator, I look at it, and it looks a little something like this. Now, if you graph it on the graphing calculator, you can kind of see it's got two places that look like zeros, one of which is at x equals 2, and the other one is at x equals negative 1. So let's try out x equals 2. And in doing so, what we're going to do is, pardon me, we're going to use synthetic division, meaning we're trying to factor out x minus 2. And we're going to use synthetic division to kind of like divide or factor that out. So we'll try that. We're going to put 2 in the box, put the 0 of that factor in the box. And we're going to use the coefficients from the rest of it. So x to the fourth, that's 1x to the fourth, minus 1, so for the minus x to the third, plus 1 for the positive x squared, minus 3, I'm having a hard time writing, for the x term, and then minus 6 for the constant. So we're going to try this out. So again, first thing we do, drop the 1. Multiply by the number in the box, we get 2. Add those together, we get positive 1. Multiply that by the box, we get 2 again. Add those together, we get 3. 3 times 2 is 6. Negative 3 plus 6 is positive 3. 3 times 2 is 6. Add those together, we get 0. So right now, what we just did is we factored out x minus 2, and we're currently left with 1x to the third plus 1x squared plus 3x plus 3. That's what those coefficients represent. But we also saw on the graph that negative 1 also seemed to be a good factor. So we're going to try out x equals negative 1. Now you could go through and redo it, but we can just keep going, because essentially we're going to be able to factor out hopefully something from here. So we're going to factor out x equals negative 1, which the factor it would be x plus 1. So we're just going to repeat this process. Again, we're going to use these coefficients, but we already have those here, so we don't need to rewrite them. So we're going to put negative 1 in our box and repeat the process. So we'll drop the first one, multiply that by negative 1, we get negative 1. Add those together, we get 0. Multiply that by negative 1, you get 0. Add those together, we get 3. Multiply that by negative 1, we get negative 3. Add those together, we get 0. So we'd already factored out x minus 2. Now we just factored out x plus 1. And the 1, 0, 3, that stands for 1x squared plus 0x plus 3. So that's as far as we can factor it. Now, we can go a little bit further, because looking at this original polynomial, the original polynomial had a degree of 4, which means it's going to have 4 zeros, or up to 4 zeros. So we have 2. We already found those on the graph. We had positive 2 and negative 1. But we can also get more zeros here. So to figure out those zeros, we're going to take x squared plus 3, set it equal to 0. Then we're going to subtract 3 from both sides, and we end up with x squared equals negative 3. We're going to take the square root of both sides. Sorry about that. We're going to take the square root of both sides, and we end up with x equals plus or minus the square root of 3. So we have 4 zeros. X equals 2, x equals negative 1, and x equals, I just realized I'm off the page. Let me move my picture there. And the last one is the last two are x equals positive or negative square root of 3.